So these are just going to be two short theorems for 10.2 because 10.2 just focuses on congruent chords. So theorem 77 says that if two chords of a circle are equidistant from the center of the circle, so in this case, the length of xp is equal to the length of py, then those two chords are also congruent to each other. So we can conclude that AB is congruent to CD. The converse of that is theorem 78. If the two chords are congruent to each other, so CD is congruent to AB, then the two chords must be equidistant from the center. So then FO is equal to OE. So those are our two theorems for 10.2. So I'm just going to do two short practice problems. Okay, here's the first. We're told that in circle P, we know that the length of PE is congruent to the length of PF. AE is a length of x plus 4, and CD is 3x minus 2. Since these two chords are equidistant from the center, then AB should be the same length as CD. We also know that since these are perpendicular to the chords, we learned in 10.1 that by theorem 74, if it's perpendicular, it bisects the chords into two equal pieces. So that's x plus 4. EB is also x plus 4. So we could say 2 times that should equal this whole chord CD, which we're given the length. So if you distribute and then subtract and move things around, we find that x is 10. But we don't want to know what x is. We want to know what CD is. So we have to plug that back in. And we'll find that CD is equal to 28. So the next question involves a regular hexagon inscribed in a circle, because there is a similar problem like this on your homework. So the perimeter of the hexagon is 48. So if the perimeter of the hexagon is 48 and there's 6 sides, then we know that each side is going to be a length of 8. The apothem, so there's a new term for you. An apothem is a segment that comes from the center of the polygon and it's perpendicular to the opposite side. So if I draw that would be an apothem. So it's like an altitude of the triangle. So the first thing we need to do is we need to find all the angles in the hexagon. Well, we know that in this circle right here, there's 360 degrees, and there's 6 angles. So if we do 360 divided by 6, we'll know that each of these angles in here are 60 degrees. And since I drew in this altitude, and I know that these are all radii right here, because it's inside a circle, then if that's the altitude of this isosceles triangle, we know that this is bisecting this angle. So they're each going to be 30 degrees. So if that's 30 degrees and that's 90, this has to be 60. So all of these angles are going to be 60 degrees as well. So we have 6 equilateral triangles. Which is nice because we can use our 30, 60, 90 rules. So that's part A. To find the radius of the circle, we're going to use this 8. So we know that all of these sides are going to be 8. And since this is an isosceles triangle, not only does this act like an altitude, but it also acts like a median. So then that means that each of these is going to be a length of 4. If these are a length of 4 and I use my 30, 60, 90 rules, well, then I know that because this is across from the 30, I can double it to get what's across from the hypotenuse. And the hypotenuse not only acts as a hypotenuse, but also as a radius. So we know the radius of the circle is 8. We can use the 30, 60, 90 rules to also help us find the apothem. So if that's 4, we know to find what's across from the 60. We tack on a radical 3. So the length of the apothem is 4 radical 3. Now to find the area of the hexagon, we don't have a formula just yet, but we could actually find the area of one of these triangles and then multiply it by 6. So to find the area of one triangle, we need 1/2 the base times the height. So 1/2 8, which is the whole base, times the height, which we just found is 4√3. It's also the apothem. And we'll get that the area is 16√3. That's for one triangle. If we want the area of the hexagon, we're going to take that and we're going to multiply it by 6 because there are 6 equilateral triangles. So the area of the hexagon is equal to 96√3. So there's a question just like that on your homework, and this is the guided steps on how to answer that problem. The rest of them will just deal with the congruent chords that are equidistant from the center.